Hello friends, in this video I'd like to solve the following problem from the Spanish Mathematical Olympiad final round 1977, problem number 1. We wish to find the determinant of this n by n matrix, which has every entry is number 3, but on the diagonal we have 8 instead. So we wish to find the determinant, and then we want to check when this determinant is divisible by 10. So my hints for this problem. First hint is to think about which operations on matrices do not change the determinant. Namely, we can take one row or one column and add it or subtract it from any other column or row, and the determinant will stay the same. And moreover, it's good to remember that determinant of diagonal matrix is just the product of its entries on the diagonal. It's even true if zeros are below or above the diagonal. It's true in that case as well. So give it a try and see you in a moment. Okay, so let's take our matrix, our determinant. So let's take our determinant 8, 8, 8, 3, 3, 3, 3, 3, 3. 3, 3, 3, 3, 3. 8, 8, 3, 3. First of all, let's take our last column. So let's take this column, and now using this column, I will take this column, multiply it by -1, and add it to every other column. And what happens if I do that? If I do that, the last column will stay the same. I will write it in green. And let's look. I take the last column, multiply it by -1, and add it to the penultimate column. So I will have 0, because -3 plus 3 is 0. Here is 0 as well, here as well, and so on. But here I will have 5, and here I will have 8 times -1 plus 3 is -5. And so on. And the first 3 columns, to be exact, will have 0, 0, 5 on the diagonal, 0, 0 at the bottom. And here we have 0. No, not 0 at the bottom, but there will be -5, because 8 times -1 plus 3 is -5. In fact, everywhere in the last row we will have -5. And here we will have 5, 0, 5, 0, 0. That's 0, 0, 0. Okay. A bunch of zeros. So now we have a bunch of zeros. And now I will take, and these determinants are the same. And now I will take every row of our matrix and I will add it to the last row. So first, for example, I take the first row and add it to the last row. So first rows will stay the same. And now let's take. So I take every row and I will add them together and add them to the last row. So 5 plus 0 and so on, plus minus 5. It will change to 0. 0 plus 5 plus 0 and so on, plus minus 5. It will become 0 as well. Likewise, here is also 0. Here as well. But the last entry will be different because I will have 3 plus 3 plus 3 and so on. How many times? N minus 1 times plus 8. So in the last entry, I will have 3 times n minus 1 plus 8. And now let's look. Now I have a triangle matrix. Everywhere below the main diagonal, I have zeros. And as I suggested at the beginning of the problem, if we have that kind of matrix, it suffices to multiply entries along the main diagonal. Because it's type of upper triangular matrix, yes. So it doesn't matter that the last column has entries different than 0. It suffices to have zeros below the diagonal. So our determinant is 5 times 5 times 5 and so on times 5 times 3n minus 1 plus 8. Okay, and now let's simplify it a little bit. How many 5s do we have? N minus 1. So we have 5 to the power of n minus 1. And after simplification, the last parenthesis is 3n plus 5. And that is our answer. That is closed form for our determinant. 5 times n to the power n minus 1 times 3n plus 5. So to be sure, let's do a verification for small cases. So for matrix 1 by 1, we have determinant of 8. Determinant of 8 is 8. Does it agree with our formula? Probably it does, because plugging in n equals 1, I have 1 times 3 plus 5, 8. So let's also check 2 by 2 case. It's 64 minus 9, so it's 55. And if I plug n equals 2 into my formula, I will have 5 to the power of 1, so it's 5. And here I will have 11. 5 times 11 and 55. It works. And now the second part of our problem. When is our number divisible by 10? When is it? Well, let's look. If n equals 1, we see that our number is not divisible by 10. So n must be greater than 1. And if n is greater than 1, this number is divisible by 5. So we need a factor of 2 for this divisibility to be true. So 3n plus 5 must be even. And it's pretty easy to see that 3n plus 5 is even if and only if n is odd. N is odd, because 3 times odd number is an odd number. Odd number plus 5 is an even number. So we have our answer. 10 divides 5 to the power n minus 1, 3n plus 5, if and only if n is an odd number greater than 1. So 3, 5, 7, 9, and so on. And that closes our problem. So I hope that you learned something new, or that you refreshed your knowledge about linear algebra and matrices and determinants. And I hope that it was useful for you. See you next time.